Okay, so I think we'll get started. So,
Okay.
hi everyone, I'm Nicole from Primary Engineer and welcome to our online interview today. So we have Asim Wadoodi with us today, who is the project engineer at Weir Minerals. Before we get started, I'll quickly run through what's going to happen during this session. So the first part will be Asim's presentation, and that will then be followed by a Q&A section. So that's accessible at the bottom of the screen, and you can type in your questions at any point during the session. And when we get to the Q&A, we'll get straight into answering as many as possible. So if you're an engineer, what would you do? The competition's main aim is to inspire young people ages 3 to 19 to look at the world around them and start designing some solutions to problems. These can be as simple as making toast or getting dressed to a worldwide problem like pollution or plastic waste. We provide these opportunities, like today with Asim, to interview and meet professionals online and hopefully give you some inspiration to start designing some solutions. So without further ado, I'm going to hand over to Asim.
Okay, thank you, Nicole. Let me just put my video up. Let me just share my screen. Is my screen visible now?
Not yet.
It should be now, I think.
Yeah, perfect.
Okay, so my name is Asim Wadoodi, as Nicole has just mentioned. I'm a project engineer at Weir Minerals. And the focus of this presentation is just to give you a brief introduction what an engineer is, what engineering is all about, and just hopefully to get you sort of interested in engineering. So if you were to Google the definition of an engineer or engineering, you'll get something like this. An engineer is someone who uses their scientific understanding of the natural world and uses it to invent, design, and build things, solve problems, and achieve practical goals. So that's a rather long-winded definition of an engineering and a definition you might not understand. But if you were to condense this definition further and you get a simple definition, you'll get something like this. An engineer is someone who basically solves problems. That's it. You have a problem, an engineer will provide a solution to that problem. That is all what engineering boils down to, providing solutions to problems. So there are many types of engineers. So you can have a structural engineer, and a structural engineer would be designing something like bridges that your cars go over, and buildings of all kinds. A mechanical engineer will work in things like cars and design engines and brakes, etc. You have electrical engineers, electronic engineers. Electronic engineers is basically anything from that goes, all the circuits that go into your phone, your television sets, your laptops, all of that has been designed by an electronic engineer. So if you were ever to open your phone or your television, you'll find that there's all sorts of these sort of little black chips on green PCB boards, as they're called. And these have all been designed by an electronic engineer. And all of these help make your phone, your television, your computers, etc. Then you have chemical engineers. So chemical engineers deal with things like chemical processes that make pharmaceuticals, like medicine, drugs, and etc. And all the things that these are the sort of things that chemical engineers do. And then you have software engineers. So software engineers basically write the computer programs that run on your computer. So for instance, this PowerPoint presentation that I'm doing is using PowerPoint, and that's been programmed by a software engineer at some point, and that's what we're using today to make this presentation possible. There are many more types of engineers, and some problems, because of how complex they are, they can require different types of engineers to work together to solve a common problem. So you might have, let's say, something like a car. A car will have a mechanical engineer working on all the engine components. It'll have an electronic engineer that will provide all the satellite navigation systems in your car, your car radio, etc. So you can see that you have mechanical and electronic engineers working together to make an end product, which is your final car. So I've just got a list of problems that engineers might deal with here. So this is a problem for a game controller. So these are your popular game controllers. But I think this is for PlayStation, and that's for an Xbox game controller. You might have seen them, you might have them. And the problem is that with people with disabilities, they might struggle to actually hold these game controllers. So engineers were tasked to come up with game controllers for disabled children. So we use engineering to design new kind of controller that can be used by anybody. And these are some examples of game controllers that engineers designed that are more suitable for people with certain kinds of disabilities. So these sort of controllers, big ones, can help disabled kids play video games too. And that's an example of a problem that's been solved by an engineer. And so the types of engineers that are required to solve this kind of problem would be mechanical. So the mechanical engineer will design the casing of this controller. So this rectangular casing and all the buttons, and he'll select all the correct materials for the casing, because you don't want somebody to press a button and then the button breaks in your hand. So the mechanical engineer will make sure that the controller is robust enough and is strong enough so that it doesn't break. And then you'll have an electronic engineer. He'll deal with the inside electronics on of the controller. So all the circuit boards and all the chips and everything that goes inside the controller will be made by an electronic engineer. You might have a chemical engineer. I'm not sure why that's on there. It's probably not needed for a chemical engineer to design a controller. And then you have electrical engineers, and you'll deal with all the wiring and make sure that it's safe. Then you've got a software engineer. He'll write the program or the code that connects this controller to the games console to make sure that it links up. And when you press a button, your game character or whatever you're playing on your console is actually responding to the controls that you're pressing on this game controller. Here's another problem. How can we produce power cleanly without hurting the environment? So I'm sure you've all heard a lot of fuss about making a clean energy. So we're always trying to make clean energy because the current forms of energy that we use, such as burning coals or nuclear power stations, they're all reducing all kinds of toxic gases into the atmosphere, which is hurting a lot of the ecosystems, polluting the atmosphere and making it difficult for us to breathe. It's also hurting a lot of animals, and a lot of species are dying because of all these gases that we're constantly producing. So engineers, again, are tasked with coming up with ways to make energy more cleanly. And one of the ways they came up with was to use solar panels. And what solar panels do is that they take energy from the sun and they convert it to electricity. And the energy from the sun is clean, it's not toxic, it's not hurting the atmosphere. And the idea is that the heat from the sun basically hits the solar panel, and the solar panel's circuitry converts that into electricity that we can all use. So this is a safer way of using or making energy using the sun. And these are some examples of what solar panels look like. So what type of engineers do you think we need to solve a problem like this? To make solar panels, again, you'll probably require a mechanical engineer to design these panels to make sure that they're sturdy and they can be fitted onto places like roofs, for instance, where the sun directly hits these panels and they're strong enough. And then you've got electronic engineers, and these electronic engineers design all the circuitry that sits beneath these solar panels and that eventually converts all this heat from the sun into electricity. And again, you've got electrical engineers working on it as well. Another problem, how can we help knee surgery with 3D printing? This is a good one. So somebody needs a knee replacement, let's say, and an engineer is tasked to come up with a way to use 3D printing to help make a replacement for a knee. So what engineers have come up with is using 3D printing, and we take a scan of the knee. A 3D model can then be created. So we take a scan of the patient's knee, and then we print the exact knee knee replacement that's required using a 3D printer, and that can be surgically joined onto the patient's knee then. So you can see this is some scans of a knee, of some person's knee who needs a knee replacement, and that's the actual scan. And that is then transferred into the 3D printer, which produces the exact knee replacement that we need, that can be then fused onto this person's knee. There you go. So again, what type of engineers are needed to make 3D printing? Mechanical engineers, obviously, because we need to actually come up with the 3D printer. That requires a mechanical engineering design to make sure the structure is solid and it doesn't break and when you press down on it or something. Then you need electronic engineers. The electronic engineers will again design all the circuitry that goes into this 3D printer. And the electronic circuitry will basically make sure that the 3D printer prints the exact thing that you require. I don't think you need chemical engineering. I'm not sure why that's there. Again, electrical engineering, software engineering. So the 3D printer usually talks to a computer of some kind on which there's a software loaded, and using that software, you can control what the 3D printer is printing. So you can design your model on software, and that model is then sent to the 3D printer to print. So you can see again that a lot of different engineers are working together, collaborating to fix problems. So it's not always just about one engineer or one type of engineer working on a problem. You have different engineers working together, mechanical, electronics, software, and all coming together to make a final end product. So this problem is about waste. How can we deal with the mountains of waste vehicle tires? So when cars are disposed of, we usually get a lot of excess parts that are left over, and one of them is actually wheels. And you can see this picture of a lot of wheels from old cars that have just been piling up. So one of the tasks that engineers have been tasked with is how to use these wheels and how to use these wheels practically. So one of the solutions they came up with is to use these old tires to make new buildings. So instead of just burning these tires away and causing a lot of pollution in the environment, their solution was to use these old tires to make building materials, and these can be used to design, can be used to build new buildings. So you can see some of these buildings have just been made actually from tires. And again, it's another picture of another one. And that's another one. And again, this solution is stopping stopping people from burning all these tires and polluting the environment. And instead of just wasting these tires, these old tires, we've recycled them and used them in these buildings. So what type of engineers do we think that were needed to solve this problem? Again, mechanical engineers. Mechanical engineers will probably do with the making sure that the building is sturdy enough and that it's strong and it doesn't fall as soon as you open the door or something to this building. Structural engineers deal with building calculations, and they'll make sure that the building is sturdy. You've got environmental engineers, and they'll assess the building and make sure that it's environmentally friendly and that it's not harming the environment in any shape or form. But engineering is not always just about solving problems. Sometimes it's also involves continuous improvement. So here's an example of a continuous improvement. How can I get to my destination quickly? So in the I believe this car is from the 1930s. In the 1930s, your cars probably looked like this. And today, none of you would probably want to get into one of these. But today, your cars look like something like this. So they've gone from looking like this to something like this. And this is an example of continuous improvement. So engineers are not always just tasked with solving new problems. Sometimes they're tasked with improving existing solutions. So the car was a solution to allowing us to go from point A to point B. And then engineers kept working on it, making it better and better and better for us until we got something that looks a lot like this. So these were one of the earliest planes that were made in, this is probably 1940s or 30s, something like that. And now you've got planes that look like this. Again, an example of a continuous improvement made by engineers. So they're making existing things, a plane that looked like this, better and better and better until it looks something like this. And I think that's an Airbus plane. So as an example of a phone, your phone 50, 60 years ago used to look like this. And now you've got phones that look something like this. Now you've got phones that have everything from a camera to you can play your music, you can browse the internet, you can play video games, and you've got everything that a computer has in your phone. And only 30, 40 years ago, your phones might have looked something like this. So again, it's an example of continuous improvement, engineers improving existing solutions. And I think that's it for my presentation.
Okay, perfect. Thank you for that. So I just remind everyone that there's a Q&A facility at the bottom of the screen. So if you've got any questions at all, then you can hand them in. We already have a lot of questions from another school that wasn't able to attend. So they've asked the list, which one? Where did you study?
I studied at the University of Leicester.
Mm-hmm. And
I studied mechanical engineering, yeah.
Yeah, and what age do you think that you started to get interested in engineering?
I think I developed a like for engineering when I was only about 8 or 9. I think I liked playing with a lot of Lego and Meccano and Connects, and some of my models used to have like motors and electronic equipment inside them, and that's what really sparked my interest in engineering.
Yeah, so I suppose, is that the part of engineering that you enjoy the most?
Yes, definitely. Building things from start to finish.
Mm-hmm. And what part of your job do you think is quite challenging?
I would say it's time management, probably. There's a lot of going on. Sometimes you have to work with different engineers, and you need, especially when you've got customers or clients who are requesting things on certain dates and they want certain things on certain times, and then you've got to all sort of work together with different engineers. So you've got to work with your software team, you got to work with your electrical team, you got to work with your mechanical team, and they've all got to work together. And it's all about organizing and just making sure that you have the time to do everything together.
Mm-hmm. And I suppose to hop on the back of that, are those the kind of skills that you need professionally to be a successful engineer? And as well, what kind of skills do you need that aren't professional?
I would say that's definitely one of the skills that you need to be a professional engineer. You need good time management skills, good communication skills, because you need to be able to talk to different people with different skill sets. So you might only be a mechanical engineer, but you might need to talk to an electrical engineer. Mm-hmm. Or you might be a software engineer who needs to talk to a mechanical engineer, and you need to sort of collaborate together, and that requires a good amount of communication skills and teamwork. So I would say, most of the examples I mentioned in this require a collaborative effort. So you need different engineers working together to solve a common problem.
Mm-hmm. Yeah, definitely. So what do you think? The school has also asked, what is the biggest or most rewarding project that you've worked on personally?
I think we made this pipeline that went from in Kazakhstan that was transporting a lot of gas. So we designed some of the pumps that were transporting all these gas through these hundreds of miles of pipelines. So I think that when there was a huge pumps, these were the size of this room, and I think that was probably the biggest project that I worked on. Mm-hmm. So these pipelines are now, and these pumps and pipelines are now installed in Kazakhstan somewhere, and I think the gas is coming from Russia to Kazakhstan, and it goes all the way to Europe.
Wow, so it's a big pipeline.
Yeah.
So what tips would you give to encourage future engineers?
To, I think, I mean, I think if you generally have an interest in things like computers and uh, computers, cars, and I think a lot of kids do, young people do, whether it's even video games, or because video games not just all about playing games, you can also take an interest in creating video games, and whatever, whether it's a iPhone that you're stuck to, you like a lot, or your your iPad, or whatever technology that you're most fond of using on a day-to-day basis, there's always an engineering behind it. And I think that's what sort of should drive your passion, just to observing those things that engineers have produced.
And I suppose, kind of on the back of that, is that a part of engineering that you wish you would have explored a bit more, or is there a part of engineering that you want to explore in your career?
Yeah, there's definitely different areas of engineering that I would like to explore further. I mean, software is one of the ones that I'd like to take an interest in more and have a go at it. I mean, currently I work as a mechanical engineer, but software engineering is something that definitely interests me, writing code.
Yeah, so is that, what kind of programs do you use on like a day-to-day basis that you wish that you'd maybe started to learn earlier that might be beneficial for viewers to get involved in?
If you're doing mechanical or aerospace engineering or civil engineering, you'll almost, and if you want to design things like, so let's say, bridges or car component parts like engine parts, then you'll almost always be using a 3D design tool, or CAD package, as they're called. So computer-aided design packages. And you might have heard, I'm not sure if you've probably heard of something like one of them is called AutoCAD or Inventor. And these are very powerful tools that allow you to sort of model things on a computer in a 3D environment. So you can actually see your model as you're building it on your computer. And these tools will be, if you're going to design engineering, you'll almost always be using these tools. You can't escape them, especially if you're doing aerospace, civil engineering, mechanical engineering, you'll always be using these tools. So if you're good at imagining things in 3D and you like drawing things in 3D, then you'll very much like these sort of tools.
One primary school in Fife has asked, why did you choose to be your type of engineer?
I really liked cars. So mechanical engineering is a lot of it is to do with studying how cars work. So that's one of the main reasons why I picked mechanical engineering. But I mean, if you like planes, for instance, you'd probably be interested in going to something like aerospace. If you really like bridges, then you'd be interested in civil engineering.
Is there a part of engineering that you think will be the future? So, like, I know that from a previous interview, I know that 3D printing is kind of involved in the future of engineering. So what do you think the future looks like?
For manufacturing engineering, mechanical, aerospace, I think, yeah, 3D will be a big thing. So you'll always have 3D printing will become a big issue. So it's definitely a good time to actually get into 3D printing, especially if you want to go into aerospace, mechanical, and civil engineering. It's good to actually even invest in buying a very basic 3D printer, and they're not expensive. So you can buy one and then experiment by yourself and how these 3D printers work. If it's something like software engineer, I would recommend looking into something like AI, reading about it, because if you're going to do anything to do with computers or software engineering, AI, artificial intelligence will almost always come up.
And again, this primary school in Fife, do you get to see your engineering inventions being used?
When I go inside, so then I will see all the things that I have designed previously or have been designed by my company. I will see them in action. So where I work currently, the company mainly designs centrifugal pumps, and which if my slide is still available, you can actually see it here.
Oh, okay.
Yeah, that's a pump. So if you go to a minerals processing site, these are usually on the outskirts of the country, and then they're in remote places. Usually, these sort of devices, or a big pump like this. But if you visit them on site, you will actually see these sort of devices being used.
So again, what has been your biggest inspiration?
My Not sure how to answer that. In what sense? I'm not sure.
I suppose in becoming an engineer, what made you become an engineer?
I'm not sure. I think it's just. I think because I used to read a lot about cars, so I really liked reading about how cars developed over time. So how something like the four-stroke petrol engine was made, or how a turbo in a car was designed, and by the people who designed them. And I think it's the people who designed them that inspired me, because I wanted to be able to do something like that.
Mm-hmm.
So mine started basically with cars, I would say.
Yeah. And how old were you when you wanted to become an engineer?
I think about 15, I would say, and probably in high school.
Okay, so quite early.
Yeah, I definitely didn't want to do something into science or engineering related.
Mm-hmm. And I suppose, what options did you choose in high school, where you starting to choose what you want to study?
Yeah, so for engineering, I would say you probably will need mathematics. I mean, people get scared when you mention mathematics, but there's no need to be, because when you actually do work as an engineer, you'll find that you're not using a lot of mathematics that you might have studied. So, but for the purposes of studying at a university or for you will need mathematics. So I would say you do need maths. You definitely need physics. Maths and physics are the main ones, I would say.
Mm-hmm.
So I mean, if you don't have chemistry or biology or English or other subjects, it doesn't really matter. But maths and physics are the two key subjects that you need for engineering, for any discipline of engineering.
Yeah. And kind of linking to the If You're an Engineer, What Would You Do competition, are there any problems that you currently are facing in your projects, or Weir is facing in their projects? Is there anything that potentially the kids watching could try and solve?
There's probably loads, actually. I'll probably give you a list of all the problems that we're facing. But it's probably about, I mean, engineering is not always just about solving problems when it comes to technology. It's always about organizing engineering companies and making sure that the process in the factory are organized as well. So some of the problems that we have is we might design something for a customer, let's say, and it might go into manufacturing, and only after the final stages of it are being completed, we find out that the customer wanted XYZ and we made ABC. And then that causes a huge problem, because we've run out of time. We need to design the thing again, and we need to make concessions to the customer and say and apologize that we're falling behind. And these are probably the main issues that we face. It's just organizing and timekeeping.
Yeah. And Fife, again, the primary school in Fife, what invention or project are you most proud of?
I mean, I think that would be the UAV that I made at university. I think I made a UAV that used a Wii controller. So the Wii controller can detect motion, as you might know already. And the task for the project was to build a UAV using a Wii controller that could detect motion by itself and adjust itself accordingly. So the task was to make sure that it levitates and basically stays in its position and does not wobble about using the Wii controller. So I think that's probably one of the best things I've made.
Mm-hmm. It's quite a unique thing to be part of, isn't it?
Yeah.
So we're kind of running out of time. What was your university degree as well?
I did mechanical engineering.
So what kind of things were involved in the mechanical engineering degree?
I think not just for mechanical engineering, but any engineering you'll do, I think you'll study certain areas within your engineering field, and then you'll do labs. So you would study, I don't know, something like thermodynamics, which deals with heat flow and energy conservation, et cetera, et cetera. And then you'll do a practical lab experiment on thermodynamics. You'll study fluid mechanics, which is all about how fluids flow. And then you'll do practical experiments on fluid flow. And that's what mostly engineering at university is like. And you'll do that for about 3-4 years.
Yeah. Again, final question. What do you like the most about your job? And is there anything that you dislike about it?
I would say what I like the most is working with different kinds of people. I think because engineering, most common problems in engineering nowadays require people who have studied different aspects of engineering to all collaborate together and to work on a problem. And I think that's the most rewarding thing that you can do, because you get to meet different people, and then you're working with different people who are experts in their own field. So yeah, like I said, you'll work with electrical engineers, software engineers, mechanical, aerospace engineers, and you all come together and you all brainstorm and you all come up with a solution to a problem. And then when you finally actually do achieve something in the end, you can all be proud of it.
Mm-hmm.
When it comes to, I think, something like what I might dislike about working, I think it is probably just the short deadlines that we have sometimes. So like I said, if your customer wants X, Y, and Z, they don't usually give you enough time. They usually just want something next week. So you don't usually have enough time to actually brainstorm and finish and design things on time. And that's probably the main issue, because everybody wants things the next day.
Mm-hmm. Yeah. Okay, so thank you, Asim. That was really helpful,
Okay.
and hopefully that's inspired our viewers today.
I hope so, yeah.
So if you've got if you want any more inspiration, you can go to the leadersaward.com website, and yeah, we'll end it there. So
Okay.
thank you.
Thank you. Thanks a lot.
Thank you, everyone.